Welcome everyone, and thank you for gathering here today. As the host said, my name is Vytenis, and I'm the head of first-line financial crime machine learning here at Danske Bank. And the title is correct. It is faking fraud using machine learning to build a worse society. And it's a bit backwards, I would say. All right, but that's for a reason. To be honest, this whole presentation is going to be a little bit backwards, because usually in Lithuania at least there is this tradition where if the guest has maybe overstayed their visit a little bit, you bring out some cake, you bring out some coffee or some tea, and then if the guest doesn't get the hint, you bring out your family photos. And you say, hey, do you want to look at my honeymoon photos, for example? That's where we'll start. That doesn't mean that you have overstayed your visit, quite the contrary, right? Let's go. This is Croatia. Very nice country. Very beautiful. These are not my pictures, I googled them, but still. Me and my wife went there on our honeymoon. It was very nice. We took the scenic route just alongside the coast. Yes, there is a highway where you can sort of cross the whole country very fast, but no tourist in their right mind would do that, right? Of course, you take the scenic route, which is this two-lane thingy just alongside the coast, right? Because you get the views, you get the very nice mountain views. You can rest at the beach, you can get to the cafes and just admire the scenery. That's what we did, right? And of course, we traveled with the car. We didn't know exactly how far we will get in a day, so we didn't plan our route very well ahead, let's put it that way. We sort of looked at where we might end up in that evening, and we just booked a hotel, right? We used a quite popular booking app. I guess you have used that as well, to sort of look for hotels in the area and just book that one in right that day. And usually we actually got quite lucky because the hotels, it was not a high season then, they just upgraded our rooms for free, so that was nice. Also pro tip, right? And that was all good and well until one morning I woke up to this. This is a bank statement from my account saying that I have just spent 600 euros. Well, I can't recall that, right? That's not very nice, okay. Maybe, but I mean, I do recall quite a lot of things, purchasing quite a lot of things, but nothing for that amount. Then I looked over to it. Okay, it's in rubles. That's not good. I don't recall purchasing anything in rubles. Okay, there is another word there, wild berries. And of course, Lenin. What the fuck, Lenin? Okay, wild berries. Let's try that. Wild berries, what is that? Okay, that's some sort of a eBay type thing, but Russian. I hadn't been there, right? Okay, I realize now that something wrong has happened. I call my bank. I tell them, hey, I think there has been some fraud on my card. And they say, yeah, sure, no worries. We'll block the card. Here's your money back. Yeah, we'll have 30 days to sort of look into the case and maybe we'll take the money back again from you if it's not fraud. But if it's fraud, all good, here's your money back. So that was nice of them, very nice of them, right? I was quite happy about that. But I had a blocked card and I was outside the country, right? And that's not a good place to be in. And overall, this whole experience, not very nice one. So we were lucky, as you can imagine, in a honeymoon means that there's another person next to you. The person also has a card. So all good, we use that one, right, to get home. But overall, this sort of feeling is not very nice. And I was working in fraud at the time, right? I knew who to call and what to do when I saw these bank statements. People don't know that. They just panic, right? This is usually not a very nice thing to experience, being defrauded like that. And so in Danske Bank, we try to prevent this kind of thing, right, to begin with. It's good that the bank that I was using just returned my money and cleared everything out. It would be even better if this hasn't happened in the first place, right? That is why in Danske Bank we're using multiple things to stop these kinds of fraud activities happening before they reach the customer. And this is the setup that we use, well, generally, in the bank. A lot of things on the screen, but essentially what we have is we have a fraud engine, which is a rule engine. It has some rules built into it, which are well-known, well-tested rules, which if you breach them, that's probably not a very good sign. So as an example, and of course these are not actual rules, I can't tell you actual rules, and I don't know them. But anyway, in principle, right, let's say you are an elderly person and you're making your first transaction abroad, somewhere in Middle East, maybe, and it's a high amount. Maybe it's 90% of your available balance. That doesn't sound right? Usually if people, especially elderly people, haven't made a transaction abroad, the first one that they would do would be to a closed country somewhere with small amounts. They will start slow, build up their confidence, and then maybe start using worldwide economy. If it's first transactions, all your money go straight to some random country, maybe high-risk country, that's probably a red flag. We would stop that transaction, pull it out for manual verification by a team of investigators, right? And then they would maybe call the customer, just verify, hey, is that actually you who's making this payment? Yeah, it's you. Are you on the phone now with anyone else? Are you talking with anyone? Did someone convince you to make this, right? All of that jazz. Another kind of rule or scenario maybe is more towards AML, which is you live a life quite normally, and then you get massive inflow of cash into your account. And then on the same day, the same amount, or very close to the same amount, goes out of your account. Yes, you can occasionally get a massive inflow of cash. You sell your car, you sell your house, things like that. But usually you don't just dump everything right away. You sort of be happy and spend it little by little, right? So this is also quite suspicious. And then maybe it would be investigated by someone, right? And one of these rules is, what do the models think about this transaction, right? Because we also have models accompanying rules in the fraud detection system. And this is where our remit comes in, first-line financial crime machine learning team, right? We build these models, we improve them or try to improve them the best as we can, and we try to stop and prevent fraud. Now, on the surface of it, it's not a very difficult task, right? It's called binary classification, binary like in bicycle, two things, two wheels, right? A bicycle has two wheels. That's why it's called bicycle. Classification is just classes or groups, right? And so we sort of try to divide things into two groups. An example can be, for example, you have a set of images of cats and dogs, and you need to train your neural network to detect, is it a cat, or is it a dog? Or you have a set of images of lung x-rays, and you have to detect, is it a healthy lung, or is it a lung with some abnormality in it? The same goes with transactions. Is it usual, or is it suspicious, fraudulent one, right? So illustratory schema is on the right here, right? You have these two sets of things, and you have to find a way to divide them. Now, if it was that easy, you would just draw a line diagonally through this screen, and you say whatever is below the line is orange, whatever is above the line is blue. That's easy, done. Right? Of course, it's never that easy, right? There are multiple issues. So first of all, data is not cleanly separable. There is a considerable overlap, right? What looks like fraudulent transaction to me, because it's high, I don't know, high amount or something like that, right? Might be usual transaction for someone else, someone maybe a bit richer. And also people's behavior change over time, right? What was maybe suspicious for me back in my teenage years, now maybe is usual stuff that I do all the time, and vice versa. And also, this data is imbalanced, quite high imbalance, right? And that's a good thing because we don't want a lot of fraud in the bank. But the fact is that we have way less fraud than we have actual transactions. The ratio is just crazy. And so, and it also brings out this sort of yin-yang thing, or whatever the host was talking about during the intro, right? This sort of thing that if you have good defenses in your bank, the fraudsters will realize that and they'll go away. Maybe to Nordea or to Swedbank, I don't know, right? But they'll avoid your bank because they know these guys, they catch fraud quite well. And so with the lack of data and with the lack of knowledge what the fraudsters are up to, you sort of tend to relax a little bit, maybe. And also it's a bit difficult to train machine learning models if you don't have any data. So this imbalance, right, this is one of the key things that we were trying to fix. Now, if you just took it as it is and just trained a model and measured its accuracy, you could get a very good model. You could get, so let's take cats and dogs, an example, right? You have an imbalance of 100 to 1, you have, let's say, 10 images of cats and 1,000 images of dogs, and you need to train your neural network to detect, is it a cat, is it a dog? You pass this thing, all these photos into a neural network, and then say, go, and the network will reach 99% accuracy very soon. All that it has to do is say, whatever you give to me, that's a dog, right? It will be 99% time, 99% time right. So how do you fix that? There are two ways. Well, there are multiple ways. Okay, let's start with the simplest one. You can just copy-paste the data, right? You take your image of the cat and you paste it until you match the number of images of dogs. You have 50-50 balance. You didn't introduce anything new, but at least you don't have imbalance anymore. That's good, right? Now your model will be 50% accurate, or maybe a bit more if you're lucky. But in principle, right, at least it's not unreasonable now. There is another method that those of you who have dealt with imbalanced data probably know. It's called SMOTE. And it sort of is similar to what people with in image recognition do. In image recognition, cats versus dogs, if they have a limited amount of one of these, so for example cats, what you would do is you would try to manipulate the data a little bit, maybe. Rotate it, flip it, make it white and gray, make the sky blue, and so on and so forth. It's still the same image, it's still a cat, right? But it's different somehow. And you can get all of these out of a single picture. So you sort of tweak your data a little bit, maybe change it, not dramatically, it's still a cat, but now you have more data points. That's what SMOTE tries to do for tabular data in principle. Well, not exactly this, but what it tries to do is you take one point of your minority class, the one that you have less of, you find its neighbors, you randomly select one of them, draw a line, and then randomly pick a point on that line. And that's it. That's your new data point, right? It's all good, it works, but at the end of it, well, you repeat it until you have 50-50 balance, but at the end of it, you end up with something like this, maybe, right? It's not perfect. There are, like, if you take a look at this distribution, well, I would imagine that we would need to cover all of this area, right? Because, well, that's probably still a bit suspicious. This one, if it was here, that would be weird, right? So, but now we have these empty spaces here. right? That's not very good. It's better than just copy pasting, not very good. So what we want to get is something like this, homogeneous distribution over the whole space. And what we did is we used variational autoencoder to try and do that. Variational autoencoder is just basically two neural networks joined in the middle. And we are trying to sort of train this neural network to recognize how does fraudulent transaction look like. So how does it look? And also a very neat trick that it has is that you can later on adjust it a little bit. So for example, these ones, right? You might know of a website called thispersondoesnotexist.com, right? That's how you pass real photos into a neural network, you train it to sort of understand what a human is, what a human image is, and then you ask it to generate a fake one, and it does. And you can also tweak it a little bit if you want to adjust the skin color or gender or so on. So we can do the same with fraud, right? There are different types of fraudulent transactions. There are like, a typical romance scam, for example. That's one way people do it. There is let's say, typical CEO fraud or something like that. That's a different kind of fraud, right? So it is a bit different. But in principle, that's what we did, right? We took this variational autoencoder and we introduced all that we know about fraudulent transactions to it. So what do we know? There is a bunch of features for a fraudulent transaction. Some of them, and they have different distributions, right? Some of them have log normal distributions of this sort of Gaussian, just skewed a little bit. Some of them have Gaussian distribution, maybe with a spike at 0, and don't ask me why that is, right? We can talk about it later. Some of them have exponential distribution, right? As an example can be, well, this is a ratio amount, but also a good example would be number of accounts with this balance, right? There are quite a lot of accounts with low balance, quite low number of accounts with high balance, right? Also, there are some geometrical features. So, for example, number of accounts that you have. And there are some categorical features, which is like account type. What kind of account that you have, it's a fixed number, right? So we try to pass all of these into a neural network. That's how the neural network autoencoder, that's what this autoencoder looks like. So you have this sort of input fixing layer, which normalizes and fixes all the input. And then you have this green part at the top image, which encodes everything into latent space. And then you have the pink part, which decodes everything back, right? And you try to train this network to sort of understand what a fraudulent transaction is. And these are our results. So how to read this? The first picture is the actual data, and these other pictures are different attempts at autoencoders, because we tweak things a little bit. And the last one is the most promising one, even though for this type of feature it doesn't actually, well, catch the distribution very well. But for other types of features, for example, for these normal distributions with zero inflated peaks, that's quite nicely captured across the board. For exponential features, the same thing, quite nicely captured distributions, right? And why the latest one is the best? Because it also managed to capture these very messy looking categorical features. This was very difficult to get. And just so you know, I didn't do this. A guy on my team did this, right? I don't know the actual workings of the model that well. But this is what we ended up with. So we had this version 3 of the model after some iterations, right? Which managed to generate fake fraud cases quite well. Except for that one little detail at the start there, but never mind. So then what, right? Now we have this trained model. What's next? Well, easy money, right? You just pump out the fraudulent cases and your awesome model is just getting better and better and better. I wish I would be able to say that. But to be honest, we didn't try it out yet. So this whole thing is still in progress, right? It's very fresh out of the press. I would like to say that it's a major breakthrough in the fraud detecting modeling, but we don't know yet. This work is still ongoing. But the fun thing is that we have this ability to generate these fake fraud cases, and they do look quite similar to the real ones. So that's it. Thank you, guys. Thanks for listening.